what, September, but we finally have 3 new equations. Special day. Okay. Range means how far away something would land. So you throw a ball at an angle, how far away will it hit? Okay, and obviously not when it rolls afterwards, but just where it hits. So range really means how far away. Really, it's going to be horizontal distance. Okay, but the idea is that we're mushing everything together. The horizontal and vertical, we're putting it together. So the velocity here isn't saying that if you have a horizontal velocity or a vertical velocity, it's saying you're throwing at this velocity. Okay? An outfielder wants to throw the ball to the catcher. He's not going to throw it, at 15 meters per second horizontally and 35 meters per second vertically, right? He's going to just throw it at that angle. That's what this is. The actual velocity it's going to leave his hand with, okay, or the resultant. Okay, so the velocity squared times sine of 2 times the angle. And what this means is you need to double the angle inside of the sine, okay? So it doesn't mean if I threw it at a 35-degree angle, it doesn't mean I certainly don't want to do sine of 2, okay? I need to make sure I have these in parentheses in your TI, whatever. As long as you have parentheses showed up, you could just do sine 2 times angle, close parentheses. Okay, so if it was a 35-degree angle, it's really saying sine of 70 in here. Okay? And divided by g, what's g always equal to? Gravity, which is what number? 9.8. 9.8. I do the absolute value to say don't worry about it being negative. Okay, it's just going to be that. Make sense? Okay. You'll see this, has anyone heard of what mortars are? Yeah. For military stuff, right? Like you'll hear about it, a U.S. base is under mortar fire. What mortars are is basically like a grenade launcher where you drop something down the tube and it fires off. They're essentially using this here. Okay, they're gonna have an angle to figure out, if they fire, the velocity would be set at 1 set velocity here. Okay, but if they change the angle, it'll go either farther away or closer in. Okay. Now, what angle do you think will get you the farthest distance? 45. All right? And just to think about it, why would it be 45 degrees? If I shoot something at 0 degrees, it won't be in the air at all. There's going to be no time in the air. There's no vertical piece of it, so it immediately hits the ground. If I went 90 degrees, it would be in the air for a very long time, but it's not going to have any horizontal component to it. So that happy medium, okay, where you have the farthest distance or the most horizontal velocity as well as the most vertical velocity, that happy medium is going to be at 45 degrees. Okay? When the baseball player is throwing to home from center field, he's going to naturally try to throw it at a 45-degree angle. Okay? Shot put, it's even the fact, they'll even try to train themselves to make sure for shot put that they're going to be shooting it and throwing it at 45 degrees because they do all that work. They don't want to be throwing it straight up, obviously. They don't want to be throwing it horizontally. They want to get that 45-degree angle. Pumpkin chunking, same thing. When they fire the pumpkins, they were going for 45-degree angle to get the maximum range. Okay? If you see maximum range, if I ask a question on a test, what is maximum range? Realize my answer is not 45. You put 45 in for the angle. In for theta. Okay? Alright. We'll pause, but here you go. You can copy that equation down. Well, yeah, no, there's no squaring on this one. Range is something a little bit different. Okay? Time is the only equation that does not have the velocity squared. The range will and the height will. Pretty straightforward, pretty self-explanatory. What angle would be the best to get the most time in the air? 90, right. You want to throw it straight up if you want to have it in the air the longest. Okay, same idea with height. Height, let me explain it before you copy it down. Let me just talk about it and then you can copy down. Velocity is squared again. Do not forget the square for the velocity, just like with a range. This symbol here having the squared, you won't have this in your calculator, won't look like this when you enter it in. What it really means though is you're not going to just square the angle, you want to square the sine of the angle. So if the angle is 45 degrees, you're going to do sine 45 in parentheses and then square it. On a TI, okay, a TI, when you hit sine and it gives you automatically parentheses, it knows if you do sine and then open parentheses, 45 degrees, close parentheses, and then square it, it knows to do sine of the angle first and then square it. Okay? On a crappy Casio, it doesn't. On a crappy Casio, you'd have to start with the parentheses, do sine of the angle, close the parentheses, and then square it. Okay? But the idea in this equation here is that you're squaring after you take the sine. Okay? Down below, it's going to be 2g. Now this is the most common mistake people will do is they're going to plug this in and say divided by 2 times 9.8. Okay, remember, if you say times with no parentheses, it thinks the 9.8 is on top. I mean, really, you could just say divided by 19.6 in your formula too, or in your calculator, that'd be fine. Alright, go ahead and copy that down. Well, yes, you definitely need to be in degrees. If we have 80, so the velocity is 80. The angle is 45 degrees, just because we made those up. Again, the angle could be anything. Unless I say maximum distance. If I say it was thrown the farthest distance, what's the height? You can put 45 degrees in. You'll know it without it being given. Okay? Alright.
Wait, so...
The way this should look in the... Huh?
Okay, keep going.
No, go ahead.
No. What I was going to ask you is you were about to say, so...
Okay. The way it should look in your calculator is this. 80 squared. If you have a TI, it will look like this. Sine, parentheses opened up for you. Unless there's a one TID one that doesn't do it. Okay, sine 45 degrees. You close the parentheses and you square it. The calculator knows that it's going to do sine of 45 first and then square. Okay? Alright? And then divided by 2, divided by 9.8. It would also be acceptable to say divided by 19.6. That might be easier. Okay? But if you did divided by 2 times 9.8, you get the wrong answer because it would think that 9.8 is on top. Okay? And really, you don't want to do parentheses and all that stuff. Okay. You should get, if you plug that in, you should get 163.3.
How do you do it in a Casio?
In a Casio, instead of the parentheses here, you would have parentheses there.
Okay.
Wait, why is there the 2 and the 9?
I think so. Yeah, 'cause it's like...
It is, but they're both on bottom. If you made the mistake of putting divided by 2 and then times 9.8 without any parentheses in it, the calculator thinks that 9.8 is on top because anything you multiply has to be on top.
We can just do 19.6.
19.6 is the easiest thing to do, yeah.
Okay, so I did that. I have the Casio, right? I did that, and I came out 236 point something.
Did you make sure it's in degree mode? It should be in degree mode. Do sine 90 and see what your answer is.
What are you supposed to get?
163.3.
0.893.
Then if it's sine of 90, it should be 1, right? So you know it's not in degree mode. Okay.
How do you